Hello, Algebra 2A, and welcome back to Lesson 34, Day 2, where we start to investigate transformations of our linear function that we have been graphing. So our linear function, remember, is a function that's x and y's produce a line. Today we're going to look at some transformations. So the word transformation comes from the word transform. So how that line is changed or moved around the coordinate plane will be determined by some patterns that we can see. And we're going to use some graphing technology to see some patterns and then apply those patterns to come up with some rules that happen when we start to apply these transformations. Our first transformation is what happens when we make our function negative. So we're going to head to some graphing technology called Desmos, and right now I have f of x equals x, which is called the parent function. It's the most basic linear function that I can make, just y equals x, or f of x is just replacing y here, and there would be my function. First, what happens when I make that function negative? So what happens when I do f of x equals negative x? There's a line that's produced. We get a line that's going now at a slope of -1. But each point that is on my red line is reflected over the x-axis to get produced into the black line. So each point that's on the red line and black line are reflections over this axis called the x-axis. So our first transformation that we're going to start to see is whenever our function has a negative in front of it, that's going to be a reflection over the x-axis. Next, what happens when we add something to our function? This would be considered adding the y-intercept. So if our number being added is positive, we're going to check to see what happens. And if our number added being negative, we're going to check to see what happens. So here, my second function, I've got f of x equals x plus c. So c is that something that I am going to be adding. So we'll start with c at 0. So if c is at 0, our line is going to be exactly the same as the parent function. But as that y-intercept changes positive, we can see that that's going to lift up my line however many units I'm adding on. So if I add on 2 units, it's going to lift my line up 2 units. So c is 2, it lifts up 2. If c is 4, it lifts up 4. If c is 6, it's going to lift up 6. So if our y-intercept, or in this case we're calling it a c, if we add on a number of units, that's going to make it go positive that many units. So here we would say that f of x plus c is a vertical shift if c is positive. Next, we'll look at what happens if c is negative. So right now I'm going to get back to 0, so that would be the exact same as the parent function. When c is negative, we're going to start to see a vertical shift down. Okay, so there would be our vertical shift down to -4 possibly, but anytime we have a number being subtracted, that's going to shift our function down. Next, we'll look at what if we put a multiplier. So this would be the slope. So what happens when the slope multiplies the x in your function? And let's take a look at the pattern that happens there. So here I have f of x equals mx. So m is representing that multiplier that's in front of my x value. So as that increases, we're going to start to see our line start to rise faster and faster. So we can see that purple line is changing. It's increasing faster and faster as we go higher and higher positive. Now in our transformations, we're going to call that a stretch. So it's going to start to stretch out. It's going to start to get more close to vertical, and that's going to represent our stretch. Now, when does our line start to stretch? It starts to stretch when that value is greater than 1. So they're using c times f of x. If c is greater than 1, we start to see the stretch happening. So here I'm looking at all values that are greater than 1. We start to see that stretch out. Secondly, what happens if we get below 1? So right here, I'm now at 1, so I'm back to the parent function. If I get below 1, we start to see our line flatten out. We can go all the way down to 0.1. There we start to see our line flattening. When my line is flattening out, that's called a compression. And a compression is going to happen anytime my value for C is between 0 and 1. And then just remember, anytime it goes into the negatives, that's going to flip us to the other side of the x-axis. So when we're graphing a transformation, we're going to look at what numbers are part of my function. So here we have g of x is 4x. So this 4, that's a value where c is multiplying the x and it's greater than 1. So we're going to start to see a stretch in this case. And we graph it just like we graph slope-intercept form. If there's no y-intercept, we'll start with our y-intercept at 0. So none that I can see, but that would just be like a plus 0. And then my slope is 4, which I'm going to use 4 over 1. So 4 over 1 means I'm going to rise 4, 1, 2, 3, 4, run 1. I can go back the other direction, 1, 2, 3, 4, back 1. So there would be my slope of 4, and then there's going to be my roughly my line. Hopefully you can draw a straighter one than that, but there would be our answer. Next, we have a negative. So a negative c out in front means that it's going to be a reflection. And then since c is greater than 1, it's also going to be a stretch. So I'm just looking at the 2. I'm not looking at the negative. The negative already told me that it is going to be a reflection. And then I'm kind of looking at the absolute value of the number. The 2 is going to make it a stretch. But again, we can graph it the same way we graph slope and intercept. So I have a y-intercept of 0. Slope is negative 2 over 1, which means I'm going to go down 2 over 1, down 2 over 1. And I can go back the other direction now that I can kind of see the direction it's going. And we can start to plot our points. So in part B, we've got g of x is equal to x plus 2. So our plus 2, our c is equal to 2, which moves it up 2. So I've got my y-intercept up at 2. And then my slope is 1. So I'm just going up 1 square over 1 square. And then there would be my graph shifted up 2 from where just plain y equals x would be. And lastly, g of x is 2x plus 1. Here we can see that since c is greater than 1 right here, we're going to have a stretch. And then since c is equal to 1 right here, that's going to be up 1. Now the notes are using the letter c, but that's also just your m and your b of your slope-intercept form. So here we'll start with a y-intercept of 1. Our slope is 2, so we'll rise 2, run 1. And we can start to produce our line. And there would be our y equals x shifted up 1 and then a slope of 2. Next, we'll take a look at what happens when we just have a horizontal or vertical line. So first, if we have y is equal to b, so y is just equal to any number, is a graph whose line is a horizontal with a slope of 0. And I'm just going to abbreviate horizontal. X equals b is not a function because it is a vertical line, which does not pass the vertical line test, and it has an undefined slope. So below here, we're going to graph both of those and also talk about their slopes. So first, y equals 5. And what a y equals any number equation means is that all y coordinates are the same. And in this case, since y is equal to 5, all our y coordinates are going to equal 5. 1, 2, 3, 4, 5. All our y coordinates are going to equal 5. So I'm just plotting a couple of points where the y coordinate is equal to 5. And we're going to get a horizontal at y equals 5. So here, y equals 5, it's going to be a horizontal. Then also our slope, our m, is going to equal 0. So horizontal lines have slope of 0. X equals 2 is where all x coordinates are the same. So in this line, all our x coordinates are 2. So I would go over to 2 and I would draw where all my x coordinates are equal to 2. And we can draw our vertical line. Anytime we have an x equals equation, our slope is not findable, so this would be called undefined. And you can see that up in our notes up here, undefined slope. So there we have our horizontal lines produced from a y equals equations, and then our vertical lines are produced from our x equals equations. And lastly, we're going to use the pitch of the roof is 1 to 8. So the pitch means that it rises 1 for every 8 that it runs. So anytime there's a construction with roofs, we're going to write our ratio like this. Most roofs are 5 to 12 pitch, but here 1 to 8 means that we have a slope of 1/8. So our 1/8 is going to equal to m. Then I looks like each square is representing 2. So if I have each square representing 2, and that's going to hit right in between a square, that's going to mean that my y-intercept is equal to 1. So graph the line that can be used to represent the left side of the roof, and then write an equation of the line in slope-intercept form. So here we'd have a y-intercept of 1, like we just talked about above, and the slope then is 1/8. So that means it rises 1, runs 1, 2, 3, 4, 5, 6, 7, 8, which would be out here. And then we could also go backwards, goes down 1, back 8. So roughly there would be a line kind of extending even beyond the peak of the roof. That would be a line representing that roof line. Then write it in slope-intercept form. That's going to be y equals, our slope goes in front of our x, y equals 1/8 x plus 1. There would be our y equals mx plus b slope-intercept form of the left side of the roof. So there we've continued to expand more on linears and starting to look at how the slope and the y-intercept start to cause transformations of our linear function. You're now ready for our lesson 34, day 2. Thanks for joining, and we'll see you next time.